The first family we're going to look at in our organic chemistry unit is the family called alkanes. When we say the word alkane, it actually relays quite a bit of information to a chemist. So the suffix for an alkane, ane, indicates that there will only be single bonds between the carbon atoms. Okay, so as soon as you see the suffix ane, you know everything, all the carbons in that molecule have single bonds. Because they all have single bonds, we refer to them as saturated. And what that means is that every carbon with his 4 valence electrons will always be bonded to 4 other atoms. Okay, the atoms might be the same, like they might be all hydrogens, or maybe they're all bonded to carbons, but because they have all single bonds, these bonds are actually free to rotate, and there's a lot of movement around those single bonds. The molecules become very flexible. Sometimes they stay in one straight line, sometimes they curve around like a snake. Alkanes are also very stable in our environment because of these single bonds. So these single bonds are given the term sigma bonds in chemistry. Okay, so single and sigma mean exactly the same. And these single bonds compared to a double or a triple bond, a single bond, a sigma bond, is very, very strong. It's very stable. It actually requires quite a bit of outside energy to try to break that bond apart. In order to name or draw alkanes or any organic molecule, there has to be some sort of system that tells us a variety of information. So we need to know, what kind of functional group or family our organic molecule is. We need to know how many carbons are in our molecule. We need to know, are there branches or any kind of special extra groups that are present. So this is sort of a standard way that we represent names of any organic molecule, but in particular now we're going to talk about alkanes. So the suffix is the ending, in this case, ane, and this tells us then that we have single bonds. The root is going to tell us how many carbon atoms we have in our molecule's longest chain. And then the prefix, and many times there's lots of prefixes, okay, not just one, but like there could be 3 or 4 or 6, it all depends, tells us how many branches are placed on the longest chain. So there's a system here that we need to follow and become comfortable with. So it is expected that you know the root words that indicate the number of carbons in these organic molecules. And many of these root names are familiar to you. You've seen them or you've heard of them already when we did nomenclature last year in grade 10 science, or grade 10 or 11 for covalent molecules. But some of the root names are different. So for carbons 1 to 4, if there was 1 carbon in your structure, the root name is meth. If there were 2 carbons in your organic molecule, the root name is F. 3 is prop, and 4 is bute. So I'm going to give you an example of a root name with a suffix. A 1 carbon alkane is called methane. Okay, and you've heard of that word. We have methane in our classroom. It's in the natural gas. And now you'll understand why it's called that. Ane means single bonds. Meth is the root word for 1 carbon. The other carbons, so 5 to 10, have root names that are familiar to you. So pent, hex, hept, oct, non, dec. So for example, if I go to oct and I write the word octane for you, octane is the primary component in gasoline that we put in our cars or trucks. And now you know oct means 8 carbons, ane means single bonds. So they have sigma bonds throughout the entire structure. You have to know these root names, okay? Like I cannot stress how important that is. And sometimes the first 4 here are a little bit harder to remember just simply because the root names are different. We aren't normally used to it. So sometimes we think of a little phrase like monkeys eat peeled bananas to try to help us remember M is meth, E is F, P is prop, B is bute. So if I asked you to draw a methane, you now have the knowledge to do so. You know that meth stands for 1 carbon, and here's 1 carbon with 4 bonds. He always has to make 4 bonds. It's single bonded, and there's only 1 carbon. So what that means is the rest of the bonds are going to be made to a hydrogen. And we'll just, again, clean up these dots. We don't like dots in a 4U course. We like lines. And there you go. That's what a methane looks like. Let's draw a butane. So you have to know, what does the root bute mean? And bute stands for 4. Okay, so remember, monkeys eat peeled bananas is the 4th word. And so what we do is we draw 4 carbons in a row, and then we can take each of those carbons and fill in the remaining bonds with hydrogen. And everything is single bonded. This is what ane means. So all those carbons are single bonded. And then I would just be putting in however many hydrogens I need so that each carbon has 4 bonds. This next carbon in the middle already has 2 bonds to a carbon on either side. So he needs 2 more hydrogens. This one, same thing, 2 more. And then the carbon on the end has only 1 bond, which means 3 bonds to a hydrogen. And if we wanted to draw the line diagram, remember, as soon as we go down, that's carbon 1, up to 2, down to 3, over to 4. Okay, and when you do line diagrams, if you want, draw in each of those carbons so that it's easier for you to see. So same thing now for heptane. I'm just going to draw the line structure for you. Hept means 7. Ane means single bonds. As soon as my pen or pencil goes down, that's carbon 1, up to 2, down to 3, up to 4, down to 5, up to 6, down to 7. And again, if you want, put carbons in at each of these points, the zigzags, so that you don't add too many carbons or not enough. And this is how you represent alkane molecules.